We've been covering the audio portion for quite a while. I'm very keen to see some numbers, to put some visuals to everything we've been talking about so far.
Great, yeah, I'll spin up my screen share and we'll get stuck in. So first thing that we'll draw attention to, and the reason I'm sharing this is because Datadog doesn't hold on to profiling data more than 8 days. So yeah, the spans for this are unfortunately lost now. If you see here, we've got this pack list service, persist debug information to storage. And it actually did two things with S3. This 59 millisecond one was when it first did a read to S3 to check if the document was already there. And then this second one is the write to S3. And it's doing this for every request. So this is where we managed to massively optimize the amount of runtime that was happening in Pack API by essentially removing these two lines and then not writing to S3 synchronously anymore, moving it to an async process.
I see. I think I misunderstood it initially. I thought it was like variable from 1 millisecond to 200 milliseconds. But actually, this is fairly consistent in that you do two S3 operations.
Yes, exactly. I think actually Amazon's guarantee is the writes will run anywhere between 100 to 200. So it's a little bit under that here, but in general, that's their SLO on write speed.
Okay, that's very interesting. What about the reads?
I forgot we were doing a read. So this was, I just opened this screenshot now and I've gone, oh yeah, we were also doing a read. I don't know what the guarantee is for those. If I just go back to past, actually, let's go to the past day and we'll find an old span from yesterday. So let's go and look at the route that we're interested in, which is give. And if we look at our give route and we sort by date descending, we'll see in this span here, we have this Redis connection, 39.2 milliseconds, taking 21.9% of the total runtime of this request. And if I now go...
This is the first time I'm seeing this. What is this thing called, this feature in Datadog?
So this is APM, Application Performance Monitoring. And one of the things that I really like about Datadog is they have excellent automatic instrumentation out the box. I did try to evaluate Honeycomb at one point, and unfortunately back then they didn't have a PHP SDK. You can use the PHP instrumentation library, but as much as manual instrumentation is great for extra insights, it's really nice to have that automatic instrumentation when you're trying to get like immediate results in production. So yeah, this is APM. There's another tool that we don't currently have on our belt called NPM, which is their network performance monitoring. And it allows you to do some really interesting things. Like if I was looking at this span here, for example, if I open this one up, in this network tab, I'd also be able to see stuff like the time it took to do DNS resolution, the CPU on each of the nodes, anything that was upstream or downstream. As long as I've got visibility of that, it would show me the health of the network on both sides. Like, I think that's the next thing that we're going to want to add, because it will just complete that end-to-end picture of what's going on a request. Is this an outlier because for some reason the CPU was spiking on the node when this request was made, or was it something not network related and it's software related? They also have, we also don't currently have this. We're considering moving our log ingestion from our existing partner to Datadog, but being able to tie all of your logs to traces as well is just huge. So it's becoming a stronger and stronger part of our landscape, and I think we'll keep adding more and more products onto it.
Yeah. So this is, just to recap, this is Datadog's APM with auto instrumentation. What we're seeing here are the traces.
Yeah.
There's also extra additions that users can add, which is log ingestion, so that you can correlate logs to traces.
Yeah.
And also the network
performance monitoring. Yeah.
Yeah. Okay, NPM. Okay, because I'm thinking like the node.
Yeah, exactly.
Okay, I see. So same abbreviation, but meaning something completely different.
Yeah.
Okay, so Redis is the green.
No, Redis is the red.
No.
Hit the pinky
one.
ones.
Oh, I see. Okay.
But you can see here it takes 300 nanoseconds now to make that connection.
Wow.
0.32% of the runtime of this request. Huge optimization.
Oh yeah. Oh yeah. What's the green one at the bottom?
Green is PDO, so this is SQL calls.
I see SQL calls. Okay.
Yeah.
RDS?
Exactly. Yeah, we're using RDS.
Cool. Okay.
We got
Okay.
plans to think about using Aurora, but it's a big
Mhm.
migration from RDS to Aurora because we'd be moving from MariaDB to, I think it's Postgres Aurora. So we'd have to see what the compatibility is like there and what we'd need to
I
change.
see.
But Aurora would give us multi-AZ, horizontal scaling.
Mm,
It would be a pretty huge win over just vertically scaling our RDS instance every time we need more capacity. But I need to find one of the other spans. Oh, let's go back to an older span because there's another really interesting performance gain that we made,
sure.
and it was by turning JIT compiling on. Okay,
Mhm.
and you should see here it spends a huge amount of time in Pack API. This graph here, I think, is called the wall time. Um,
Mhm.
so we spend a huge amount of time in Pack API. We don't spend that much time in PDO, Redis, curl, or any of the other services. So my initial question here when I was looking at this is we've got quite a large running time of up to sort of 200 to 300 milliseconds, but most of that 200 to 300 milliseconds is spent in our code. It's not in any downstream service. It's not calling out to Redis or um, MariaDB. Why is that the
Mhm.
case? The reason it was spending so long there is every time the application booted,
Mhm.
Laravel was having to do all of its startup, so loading the framework into memory, and then doing any of its boot stuff before it hands off to actually process the request. But one thing that we can do, I think since PHP 8, is use JIT compilation. So you
Mhm.
can tell it how many megabytes of memory you want it to hold, and
Yep.
then it will just allow any process that's trying to start that application, just JIT compile it. And I think that ended up also saving us about, as we can see up here, after it
Mhm.
got deployed, the wall time went down to like 20 to 30% from, in some cases, like 80%. Like we
Mhm.
massively reduce it. We can see the further we go this way, the less time we spend in the API itself. These troughs, by the way, is when usage starts to fall off due to us being out of our busiest periods of the day. The ones where
Mhm.
you've got a tighter grouping is when we're sort of in our busiest hours of the day.
Yeah, that is a good looking graph. And requests and errors, I can see the number of requests as it's going up,
Yep.
which is the first graph to the left.
Yeah, it's crazy if we look at the past month
Mhm.
how different different the usage is. Yeah, like 400k requests. Yeah, yeah, like our
Yeah.
busiest day, 440,000 requests. That was Black Friday. Just coming up to Black Friday.
Mhm.
It was, yeah, very
Wow.
very busy. One of the annoying things that I want to filter out though is from errors. Client side
Mhm.
errors are getting counted towards our error quota, and
I see.
one thing I've done is I've created an SLO for of uptime of this service,
Mhm.
and this is defined as being the total amount of requests from this service grouped by clusters minus the amount of errors, and
Mhm.
then the total events is obviously all of the requests altogether. And we can do A minus B to have hits minus errors gives us current usage against the total amount of hits, and it's
Yeah.
currently reflecting like a 99.847% uptime, which is great,
Mhm.
but it should be much
Mhm.
higher than this because most of these errors are actually 400s where someone has scanned something wrong and then it gives us a 400 error. It's
I
great to
see.
have visibility of that because it allows us to see why are operators misscanning, are we doing something wrong, and we can then go tie that back to a session replay and see what they were doing. But we only really want to be counting 500 errors in this. But I
Yeah.
haven't yet figured out how to define a custom metric that will allow me to only include 500. So if we look here, you can see the trace.laravel.request.errors is a predefined metric that includes all of these codes, and I can't edit this metric. Something for me to dig into as I'm
Yeah.
sort of getting more au fait with
If
Datadog.
someone's watching this and they know how to accomplish this, or they know someone that might, leave a comment. This is something new. Leave a comment below. Let's see how that works.
Yeah, that would be great.
Anything else in Datadog that you wish was different?
I've been really impressed with just how much tooling they have. Um, I can't really fault it at the moment.
Hmm.
There's a steep learning curve when you first come into it. Creating dashboards for the first time feels a little bit scary when you're trying to work out how do I pull this metric from this service. They do a lot with their auto completion to help you find those things, but if you're a new user and you haven't really got much of an idea on how to provision a new dashboard, it can be quite intimidating. One other thing though that I would like to show, this is the session replay stuff.
Hmm.
Um, So it's called RUM, Real-Time User Monitoring.
Mm-hmm.
And if we scroll down here, I added some extra headers to what Datadog sends, and I can filter by my user ID. And if I
Mm-hmm.
filter by my user ID, I can see all of the replays that happened within the past week for my user. So
Mm-hmm.
the reason this is really awesome is a lot of times we have reports come in from operators saying the system is slow, or I tried to click this button but it didn't work, or I can't see this button on my screen. And whilst those things are all quite confusing to the operator, it's really hard for us to visualize that feedback. But
Mm-hmm.
with real-time user monitoring, because we're still currently quite a small operation, we just capture 100% of all sessions across all operators across all sites. We don't do
Mm-hmm.
it for our client-side reporting. We only monitor, I think, 5 or 10% of client-side sessions. But for internal sessions, we monitor everything. So if I come here, I can see my entire session end to end. There's going to be some
Mm-hmm.
stuff missing because the image links have expired now. We use signed image URLs, but normally there's images here for all of these products. As I'm scanning, I can see exactly what the operator would be seeing. So when I'm trying to triage a defect that's came in,
Mm-hmm.
I can go and tie it back to a specific replay and then validate what the operator is telling me is correct. It's a really, really powerful tool. Yeah,
That's really cool. So you can see what users did when they encountered an error. So from the error, you can go and link it back to the actual session, to the actual user session.
exactly.
Wow, and you can really understand. Wow, that's really powerful. I
Yeah.
like that.
There was also a dashboard. I'm going to see if I can find it. Oh, they might have hidden
George, the
it.
George
George.
dashboard.
His dashboard is awesome.
Yeah, we can show it if you want.
Yeah, I might have to bring it up in a minute. There we go. So you can get like an overview of our front end application,
Mm-hmm.
and we can see like largest content for paint from a front end perspective is like how long it takes before I think the DOM becomes interactive. So in some of these
Mm-hmm.
cases, for whatever reason, these were really spiking. I haven't actually looked at this in a while, so I haven't dug into why
Yeah.
that's the case.
Right after this, right after we're finished.
That's it. This has now piqued my interest.
Wow,
uh,
great.
but yeah, it's really awesome to have analytics on your front end as well, so you can start
Mm-hmm.
diving in and debugging why things are slow there.
Yeah.
Right, so yeah, let's go have a quick look at George's dashboard.
Mm-hmm.
And I think this is a really great example of a well thought out and managed dashboard. I think each one of these sections here is called a power pack in Datadog.
Mm-hmm.
And a power pack is a collection of graphs that are sort of structured under a header. So if we expand one of these, you can see a bunch of dashboards that are all grouped under this specific backlogs category. So an
Mm-hmm.
events backlog is when we've just received a huge number of events and we want to see how long it's taken us to process that backlog. I think over peak we had some times where we were spawning too many events from new pack, and that was basically causing us to be in an infinite cycle of we can never clear the events. And I remember my friend and I, Alex, we set up in the office and were spinning up additional workers on other machines to
Yeah.
try and clear the backlog, but it was like putting an extra
Did
1,000
you say
events.
Alex?
Yeah,
Did you say Alex? So Alex and Alex.
yeah.
So there's not just James and James. There's Alex and Alex.
There's
That's
Alex.
okay. So Alex and Alex.
There's
We're
Alex and
spinning up what?
Alex.
Workers?
Yeah, we're spinning up workers, but at work I'm half point, so it's
Yeah.
half point and Alex were doing
Right.
it.
Half
Yeah.
pint. Of course. Of course. Yeah. Yeah.
Yeah,
Okay.
yeah, but we were just manually spinning up these workers to try and get the load down, and then
Mm-hmm.
it occurred to me that one of the things that we were doing that was very expensive is every time that we do a scan, we were dispatching an event to the legacy application to say recalculate the amount of stock that's now available for this SKU. But
Mm-hmm.
previously in the old system, because we'd only emit that event after the entire order had been packed, it would only have to run that event once. Whereas now, because I'm doing it on every scan, it runs that event multiple times through the life cycle of completing an order. And that was causing us to have this huge event backlog that was just like going through the roof when everyone was using new pack. And we hadn't seen
Right.
it prior to peak because we didn't have all of our operators using new pack before peak.
Mm-hmm.
So yeah, it's always interesting at peak because we've always deployed something new and big, and we're getting lots of great wins from it. But then there's also these scaling challenges, and sometimes
Yeah.
it's just that all hands on deck, get upstairs,
Mm.
spin up some workers to try and clear a backlog while you're figuring out what's wrong. Yeah, so that's sort of why I described it as chaotic and productive this year.
We're almost at the end of this amazing conversation, for which I'm very appreciative. I'm wondering, is there anything in the tech industry, in the tech that you use, that you wish was different, easier, better, faster, more reliable?
One of the things that I've learned by moving to an architecture role, it's one thing to be an architect and want to pick out the nicest, shiniest technologies that are going to be able to deliver the fastest solution. But it's another thing to think about the experience and capabilities of the team that you're working on and how you're going to maintain and continue to support a system after it's in place. And so what I mean by that is I love other languages. I like writing in Go, and I think it's a really fast language. And probably we could have squeezed some more performance out of this application if the backend was written in Go. But the capabilities of the majority of the team aren't in Go, it's in PHP. And sometimes when you're thinking about the best thing to deliver, the most important thing is actually to think about the competency of everyone that's going to be supporting the thing.
Mm.
So as a PHP software house, we make PHP work, and as PHP continues to evolve, it's getting faster and faster, and yeah, it's running in production, achieving the goals that I wanted it to achieve. But I do think we could have got there quicker if we'd picked a more performant server-side language.
If you enjoyed this, there is a podcast that goes with it. Check out pod.gerhard.io. For the full conversation, go to makeitwork.gerhard.io. Until next time.